Hello and welcome to the Codercy channel. In this video I will show you how to implement a custom TriFunction in Kotlin, and additionally we will learn what exactly functional interfaces are and how some conversions can help us to achieve a better and a more concise code. Before we start, just a quick reminder. You can learn this and many more from my Ultimate Kotlin course, for which the link you can find in the description for this video. Let's start everything with defining what exactly is a functional interface. Well, it is nothing else than an interface with exactly one abstract method. In Kotlin, we can define it using the fun keyword. Let's take a look at the following example. Fun interface, my functional interface, and right here we have to declare exactly one abstract method. So let's call it fun method. Right now it is working perfectly. Let's see what happens when we add another one. Fun, another method. As we can see, the code will not compile whenever we try to implement more than one abstract method. On the other hand, we can have multiple non-abstract ones. So fun, non-abstract, let's declare it, and we can see that if I delete this one, everything works fine. I can duplicate this one, non-abstract, too, everything works perfect. Okay, so with that being said, what exactly is a TriFunction then? Well, the TriFunction interface is nothing else than a functional interface with 3 input parameters and 1 output. With that being said, let's see what exactly is a TriFunction. Well, the TriFunction interface is nothing else than a functional interface with 3 input parameters and 1 output. To better visualize that, let's add example to our code. Fun interface custom TriFunction, and it will have 4 generic types are, and we have to define exactly one abstract method. So let's add fun, some fun, and it will take 3 types: t of type t, u of type u, v of type v, and as a result type we will have r. Following, let's add a test function which will utilize this interface. So let's call it example fun. This one will be generic too, so let's define u, v, r. We have to specify all 4 types. Example. And this function will take 4 parameters. The first one will be t of type t, the second one u of type u, third v, and the last one will be our function. So I'll call it function, custom TriFunction, and we'll specify vr right here as well. As a result, I would like to return r as well. R, and here we go. What I would like this function to do is to simply return the result of the function that will pass. And although this example is a bit trivial, in real life scenarios we may want to use this strategy to keep our code open for extension and close for modification. Let's introduce val result, a new variable, function, and it will evoke the function that we pass right here as an argument with other arguments t, u, and v. As I said, in the real life scenarios we would put some logic here, and lastly we simply return the result. Excellent, with all of that done, we can finally use the interface and implement the code responsible for invoking the example. So let's start with adding a new class. src main Kotlin, and right here let's specify a new Kotlin class. I will call it custom implementation. Custom implementation. Excellent. As we could see, our custom TriFunction is nothing else than an interface, so what we can do here is to implement it. Let's go with custom TriFunction, And as a type, let's specify, for example, string, long, int, and double. In IntelliJ, we may want to use Ctrl+E to implement members. Some function, as we can see, IntelliJ already applied correct types to T, U, and V arguments. Right here, similarly, normally we would put some logic, and for example, let's return 10,0 because we need to return the double type. Nextly, we can get back to the main class right here, and let's introduce some main function, main, right here. And what we would like to do now will be create a new instance of custom implementation, val custom implementation equals custom implementation. Excellent. The last thing we will have to do will be to simply get the result, val result equals example. We can pass some string, then some long value, integer, and lastly, simply pass custom implementation. Let's verify what will be the result then. Println result, Shift plus F10. Let's wait until it builds. And we can see that the result is 10, just like we implemented in custom implementation. Of course, depending on our case, this class could be changed to a Kotlin object as well. Instead of creating a new instance here, we would simply use custom implementation instead. Let's rerun, Shift plus F10, and we can see that this works perfectly. And although this solution works, we don't necessarily always want to explicitly define a new class for our case. Maybe we want to pass a very specific logic which definitely won't be used anywhere else in the code. For such one-time operation, we can use the anonymous object. So let me get rid of this. Ctrl+X, and let's define a new anonymous object. Val anonymous object, and now object custom TriFunction. Similarly, I will provide string, long, int, and the result will be of double type. Let's open up brackets. Again, Ctrl+E, and we override the function. Similarly, let's return 10,0. Excellent. As we can see, the instance of the anonymous object looks almost exactly the same as the previous example, with one important difference: it does not have a name. And as I mentioned previously, this approach may be really helpful for one-time use. Again, we can verify whether it works. So val result equals example. Now let's specify string value, long value, integer, and our anonymous object. Finally, let's print out the result, Shift plus F10. Excellent, works perfectly. And although this works, in Kotlin we can make it even more concise with some conversions. In Kotlin, functional interfaces are also known as single abstract method interfaces. So instead of defining anonymous object, we can make use of a sum conversion, which allows us to use lambda expression instead. As we can see right here, IntelliJ suggests that we could convert that to lambda, and I will show you that with Alt plus Enter shortcut, we can do that pretty easily. As we can see, after that, the code becomes much cleaner and better to read. So right now we assign our lambda expression to anonymous object and pass it to our function. Moreover, instead of doing so, we could simply take this one and put instead of the argument. Additionally, in Kotlin, if the last argument passed to the function is a function, we can put it outside of the parentheses. So move lambda argument outside of the parentheses. So this time, instead of defining explicitly an anonymous object, we pass that as an argument to our function. Moreover, we don't have to define types explicitly because Kotlin compiler will be able to determine them. As the last example, let's take a look at the high order function and let's implement it without an interface. Lastly, let's take a look at the last example, because in Kotlin, instead of defining and explicitly providing an interface, we can use a high order function. But what is it? Well, it is nothing else than a function which takes another function as an argument or returns a function. So, at the end of the day, instead of explicitly creating a custom TriFunction interface, we can define a parameter of a function type. I know this might sound a bit tricky, but let's take a look at the example. Right here, instead of our function, we can simply provide which types it should take, like T, U, V, and the return type of the function that we would like to return. Of course, we have to fix it right here because this function does not have the SumFun method. Instead, we can call invoke, and moreover in Kotlin we can completely get rid of that, and this will be the equivalent. When we run our example, once again we'll see that it will work perfectly. And this approach might be a great choice whenever we would like to have a TriFunction without explicitly defining a new interface. So today we started with a custom TriFunction as an interface, anonymous objects, and we end up with a single line which is called right here, and a way less code to write. And of course, the final solution which you will choose in your case will depend on the case that you are trying to solve, but I hope that this video will help you to make it way easier. And that's all for this video. Don't forget to subscribe and see you in the next ones.